Okay, guys, on to page 3. Um, the monthly revenue achieved by selling is so this is my revenue. The monthly cost is this. How many wristwatches must the firm sell to maximize revenue? So anytime we're talking about maximizing things, guys, that means we're graphing it on decimals. So I know you can't see my screen, but you could graph it on decimals yourself. I'm just graphing this one right there. And if I graph this thing, I know it's going to look like that, and it's going to have a maximum there. So I'm going to go 75x minus 0.2x squared, and I'm going to zoom out or adjust my thing, adjust my window. I can see it going up and up and up. Now I can see it go down. So this is going up way far. So just kind of keep going until you see the peak. This goes to 187.5 and 7031.25. So how many must wristwatches? So think about that. My input is X, which is going to be wristwatches. My output is revenue. So if I'm looking at that, um, how many wristwatches must they make to maximize revenue? 187.5, which I can't really do, can I? So I'm going to round that 188 watches, okay? And 7031.25. There's what? Now if you left that at 187.5, I'm going to be okay because you've realized I need to maximize that go, but I wouldn't but I'd rather see it as a whole number. Okay, profit is given as revenue minus cost. So my profit is going to be the revenue, which is 75x minus 0.2x squared minus my cost, which is 32x plus 1750. Yeah, revenue minus cost. How many wristwatches must this firm sell to maximize profit? So if I'm going to maximize profit, I mean I'm graphing this. So I'm going to graph this whole thing. So that's going to give me another quadratic with a point like that, where the x is going to be the wristwatches. So I'm going back to Desmos, and I'm graphing my revenue minus the cost. And remember to put things in parentheses like I do here. 32x plus 1750. Okay, and I'm just kind of scrolling out until I see that. There I go. I finally found it. That's going to give me the point 107.5 and 561.25. So how many wristwatches must they do maximize profit? 108 watches. If you left it as 107.5, I'd be okay. And then the profit is going to be 561.25. That will be my monthly profit. Okay. So this is a decimals kind of question. A farmer with 300 meters of fencing wants to enclose a rectangular plot that borders on a river. So I've got a river, and I'm going to plot a rectangle, which means I'm going to have a width and a width and a length. And these three things have to add up to be 3,000. So in other words, 3,000 is going to be two widths plus a length. And my area is going to be my length times the width. So if I'm going to solve this for width, I'm going to solve. Actually, you know what? I'm not going to solve that for width. I'm going to solve it for length, because length is 3,000 minus 2 width. Because remember, to maximize this is another maximizing thing. What's the largest? That's the maximum. I'm going to graph this and put it in decimals, but I'm going to graph the area because it wants to know the largest area. And area equals equal to the length, which I just solved, is 3,000 minus 2 width times the width. So I'm going to graph that. It's going to give me a maximum like that. So if I graph that in decimals, I got 3,000 minus 2 widths times the width, and I just have to replace that W with an X. Okay, and I want to maximize that. So I'm just kind of scrolling out until I see it. This is going to be a big big thing, isn't it? Wow. Finally, I get there and I adjust it, and I get the point 750, 1125000. It's the largest area. Okay, this is the width. So this is 750, that's 750, and this is the rest of it. This is the area. So 1,125,000, and this is meters, so square meters. Okay? So when you're looking at these areas and you're graphing them, be very clear that you understand input and output. This is my input, it's the width. That's my output, that's the area. Okay. Now on to some, oh, look at this. I need to buy sod. Put my front and backyard. The dimensions of your front yard are 40 by 21.5. So 40, 21.5. Dimensions of my backyard are 37 by 17. They're only giving me 2 dimensions, so I'm assuming they're rectangles or something like that. Okay. I can buy sod at this nursery for $7 a roll, or so I need to find my area here. So the area of each of these is the length times the width. So I'm just gonna go 40 times 21.5 gives me 860 for this area, and 860 square feet. 37 times 17 gives me 629. And if I add these together, plus 860, I get 1489 square feet. That's how much I need to buy. Okay, so first, anytime we're doing these design kind of problems, figure out your area or your volume first. Now, I got 2 options for cost. I can do Green Acres Nursery, and it says $7 a roll. Each roll is 10 square feet. Well, if I divide that by 10, 1489 divided by 10, that means I need 148.9 rolls. So 149 rolls I need, and each of those rolls is $7 times 7. That gives me a cost of $1,042.3. Okay, and then I could also buy it by the pallet at Home Depot. Each pallet is $4.99 for 55.6 square yards. Wow. So this is in square feet. I need square yards. Well, a square yard is 3 feet by 3 feet. This is a square yard. And 3 times 3 gives me 9 square feet. So if I divide this by 9, 1489 divided by 9, that gives me 165.4. 165.4 square yard. Okay. And each pallet has 55.6 square yards. So if I divide that by 55.6, I realize I need 2.97, or that's close enough to 3 because I'm not going to be able to buy a piece of a pallet. 3 pallets and 3 pallets. So let's back up. First, I converted this to square yards by dividing by 9, because there are 9 square feet in a square yard, because 3 feet by 3 feet makes 1 square yard. That gave me this many yards, and then I divided this by 55.6 square yards. That told me how many pallets I needed. 2.9 something rounds up to 3 pallets, and 3 pallets at a cost of 3 times $4.99. That gives me a cost of $14.97. Green Acres is going to be my cheaper way to go. Okay. Well, bummer on you, Home Depot. Okay. Let's look at some statistics for the last little bit, shall we? Absolutely. Okay. 2,500 freshmen took a bio test. The scores were normally served a mean of 78. Use the curve above to label the mean. So this is 78. And if the standard deviation of 5, I need to add 5 every step here. So 75, 8 plus 5 make 83, 88, 93. And if I subtract 5, 73, 68, 63. Okay, what percentage scores lies between 73 and 83? Well, 73 to 83 is one standard deviation out. Well, that's just the empirical rule, because one standard deviation, remember, 68, 95, 99.7 is our rule for between one standard deviation, 2 and 3. Cool. And that's it. Okay, I'm going to keep going on the next page for this because this problem goes right there. Okay, so actually I might probably just do pages 3 and 4. Let's move on. Okay, I'm going to keep this curve here because I really want to reference it. What percentage scores are less than 83? Well, less than 83, 83 is one standard deviation above, right? You can see it right there. Right there, yeah. And if there's 50% here, that's 50%. And this is 68 from here to here. Half of this is 34. So 50 plus 34 make 84%. Okay? What about are less than 68? What percentage scores are less than 68? 68 is 2 standard deviations down. So 1, 2. And I want to do that, less than 68. Well, if between 68 and 88 are 95, if I take 100 minus 95, that gives me 5. So that means there's 5% on this tail and on this tail. If I divide that by 2, I get 2.5%. Okay, now I get another question of how many students are between 68 and 88. Well, 68 to 88, where's that? Where's that? 68, that's down 2 standard deviations less. And 88 is 2 standard deviations more. Oh, well, that's just 95% of students. Okay, 95%, but this is 95% of 2,500 because I don't want percent, it wants how many students. So if I go, what's 95% of 2,500? 0.95 times 0.95 times 2,500, 2375. Now, if this ended in a decimal, you would have to round that up or round down to the nearest whole person. So we can't have decimal people. Okay? So whether you round it down or round it up would be that it would be both would be correct because there's good arguments for both. Okay. Now, let's look at this. Just pure z-scores. Use your z-table. So I'm going to pull up my z-table. And dang it, I don't have one handy. I'm just going to pull up one online and I'm sorry, I didn't mean for this to drag on. I'm going to pull this online. I'm going to print it up right here. There we go. There we go. There we go. I can print this really quick. So I'm looking up on my z-score. Now remember on your z-table, the z-table gives the percentage less than something. Okay, so let's look at this. And the way this is printing, you can hear it printing in the background. Z is less than 1.13. There's 1. There's Z is equal to 1.13, and I want less than that. So if I look on my Z table, I find, this is 1.13, which is up here. Positive 1.13. So I got to go all the way over there. Positive 1.13. And if I look at my positive Z table, 1.1, 1.10, 1.11, 1.12, 1.13, there's 0.84, 84849. There it is, right there. Yep. 1.1. Oh, that's 1.0. 1.13. There it is. 8.7076. See it? Because I got to go 1.13. 87076. So 0.87076. Okay, cool. Now I want between negative 1.34. So negative 1.34 and 0.74. Remember, for the between, I gotta find the percent below here and the percent below here, and then subtract them. Well, negative 1.34, negative 1.3, negative 1.3. Here's 4, and yeah, 4 and negative 1.3, 0.90, 0.09012. So 0.09012. Because I know I'm going to find the percent of this bigger one and subtract the percent of the smaller one. So 0.74 gives me 0.7. There's 0.7 and 0.4. There it is, 0.77035. 0.77035. 0.77035. And if I subtract those, 0.77035 minus the 0.09012, that gives me 0.68023. Cool. Now, if I'm going to do the negative 2.53, okay, negative 2.53 is right down here. Negative 2.53, and I want above it, so I want there. So I know that I'm going to go 1 minus whatever the percentage there. So 2.53, that's a positive z-score. I go here. Oh, that's negative ones. Can't do that. 2.5, there it is. 2.5 and 2.53. There it is, 0.99430. There it is. So 1 minus 0.99430, that gives me 1 minus 0.99430 gives me 0.0057. Mine's inside notation, but that's what that means. Okay, cool. Now. I'll keep those handy because I think I'm going to use them in a second. When Tiger Woods hits the river, his distance ball travels follows a normal distribution with a mean of 304 and a standard deviation of 6. What percent of Tiger's drives travel less than 290 yards? So if I'm looking at this 304, I'm going to get a good idea. Here's 304. And if I go 6 less than that is 304 minus 6 is 298. Minus 6 is 292. Minus 6 is 186. So 290 is somewhere right there. So I can see that's going to be a very small thing. First thing I need to do is find the z-score for that. So z is equal to that number, the 290, minus the mean, which is 304, all over 6. If I find the z-score for that, 290 minus 304 all over 6 gives me negative 7/3, which is negative 2.3-ish. Negative 2.33. And I'm only going to go to 2 decimals because that's where my table goes. And I want to go travels less than that. So I want to know less than that. So I pull up my z-score table and I go negative. Oh, that's my positive z-score table. Negative 2.3. There's 2.3 and 2.0123 there. And I get 0.00990. So 0.00990. There it is. Okay, now determine the mean and the sample standard deviation to the nearest tenth. Okay, this is something, the mean, that's reasonable. Sample standard deviation, that's not. So I'm going to go to decimals on this, and I'm going to make a list by putting this in a bracket and this in a bracket. And if I go to decimals and I find that, and then I can just use the statistics functions on that, that will give me a mean of 89.5. I already typed it in just a bit ago. So, and a standard deviation of 6.626. Let's just go there. Okay? That's that. I will not expect you to find that by hand, but on decimals I would. Approximate the margin of error for a 95% confidence interval and round to the nearest tenth. Well, the margin of error formula, remember, on this is for a mean and a standard deviation. The confidence interval, which is down here, was going to be the mean plus or minus 2 for a 95% times times the standard deviation over the square root of the sample size. I'll do that in a second. So the margin of error here is just going to be that, 2 times the standard deviation, which was the 6.626 over the square root of the sample size. What's the sample size? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? I think I counted that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. So if I type that on my calculator, 2 times the 6.626, and of course, if I rounded that to different places, it'd be a little different, over the square root of 12 gives me 3.826. 3.826. Now, and my confidence interval is going to be 89.5 plus and minus that margin of error, 3.826, which is going to give me, if I go 89.5 plus 3.826, I get 93.326. And if I go 89.5 minus that 3.826, that gives me 85.674. Cool. Now, interpreting that, what that means is that I'm 95% confident that the mean temperature, and this was various locations in Utah. In Utah, on July 4, was between these two temperatures, 85.674 and 93.326 degrees. That's what that means. If a smaller margin of error is desired, what should be done? Well, there's really only one thing you can do: increase the sample size. And that's it, guys. On to the last page.